I'd like to talk to you a little bit about kickstarting the culture of observability in a DevOps environment. And so since DevOps is sort of like in the air, it's in the culture, that's very common in the industry nowadays. I want to start off with a little bit of history. Like, does anyone know here, like, what's the origin of DevOps? Like, how old is it? Any yes? So the answer is that in 2007 and 2008, so I did a little bit of digging into this because I was a little curious. And there are several sources for this, but it started off with Patrick and Andrew Schaefer having a discussion about the frustration of trying to do this particular release that required some asks from ops and requires some asks from the developers, and the two teams were just not like talking the same language. They were just like completely different orbits, different values, different practices, and this was just leading to a lot of confusion. And so they were like discussing and like exchanging notes, and they came up with this term called agile infrastructure, which is how to make DevOps make operations more like development. And I really like this term agile because you'll see it's quite germane to what we will discuss later. In 2009, there was this really influential talk done by John Allspaw and Paul Hammond, where they discussed, how does dev and ops cooperate at Flickr, where they seem to be doing a much better job at getting along with each other. And in fact, this talk was given at an O'Reilly conference. And just a few weeks later, the first DevOps Days conference was launched. So, it's almost 10 years now that we've had DevOps formally recognized as a practice. So let's just like hold that thought. Let's keep that in mind. And I'm going to switch tracks a little bit. So think of this as Act 1, Scene 1. I'm going to start with Act 2, Scene 1. Going back into ancient history, this is right after I finished graduate school in the year 2000. I know what you're thinking, but it's 2000 AD, not BC. So this is my first job out of graduate school, right? I was working at this company called Quick. It's not the Quick that's currently here. This is a much older company, of course. And we built a collaboration-based customer service product. It was actually a pretty fun product. But this is like way before any of the DevOps thing, and it really shows. It was like a classical, old school kind of shop, relatively small startup, like 10-ish servers, 5 services. And like I said, it was like totally conventional. Like we had developers and we had operators, and I was a developer. I wrote software, kind of threw it over the wall. And we had an operations team that actually did builds and deploys and all that good stuff. Great company, but unfortunately, you probably know, 2001, there was 9/11, and then the dot-com implosion, and I promptly lost my job. I had an H-1B, and all right, what do I do now? Luckily, I found another job. My second job was at Google, and this was year 2002, before there was Gmail, before there was Android, before any of that stuff, and Google was just a plain search company. That's all they did, right? But look at the difference in the environment. At that time, Google already had over 30,000 servers. Very cheap and inexpensive. They broke a lot. So a lot of the smarts were actually in the software that used those boxes. We already had over 100 plus internally and external facing services, even though all you really saw was a search box. But it was very complicated under the covers. And they already had at this time a very large scale metrics and logging system. So what was I doing at Google? I worked in this team called production. And production really did Google's infrastructure as a service to all our internal engineers. So we did everything like building monitoring, building access control, machine management, all that kind of stuff. And we also were the team that was helping out manually roll out Google's indexes. They would run this job every week, and they would break up the web into 12 partitions, and they would index them, and we had to manually push out those partitions to every single data center, working very closely with the search team, of course. Every time there was increased search volume, we would have to, for example, provision more servers. We wrote a lot of cluster management software. We carried the pagers for that software. And it was a very common thing in the Google engineering teams that if you wrote a service, you carried the pager for that service. So now, obviously, I don't know what other companies were doing at this time, but my claim is that Google did DevOps before it was called DevOps. And this was a clear 5 years before those discussions about agile infrastructure. All right, so Act 2, Scene 3. My third job was at Facebook. At this time, Google was still the don't be evil company. You probably remember those days. Facebook had its own motto. Does anyone remember what it was at around this time? There you go. It was move fast and break things. What would you do if you weren't afraid? And there were lots of like cool takes on this, like our micro kitchen had break fast and eat things. There was like all sorts of stuff, but like this was the culture at Facebook, right? They moved very fast, wrote software very quickly, deployed it. Uneven quality because things did end up breaking, but the emphasis was on growth. It was not on monetization at the time. And so it didn't matter that you couldn't poke your friends, which was pretty much all you could do at Facebook in the time. Or you couldn't pet your virtual cows, which was Farmville. I don't know how many of you remember all this stuff. But something started happening. Facebook started making money. And then breakages started mattering. And then they changed their motto. Do you know what it changed to? You know? Yeah. So it's the ultra interesting move fast with stable infrastructure from the move fast break things. So clearly 5 out of 7 on the cringeometer. A very admirable sentiment. We all know why they changed it, but of course it's a little bit lame on the marketing side of things. It didn't really stick, didn't really seem as sexy as move fast, break things. But the question is like, how do you move fast without breaking things? What is that change in mentality? But as with Google, Facebook had a very strong culture of observability. There were a lot of engineers that came from Google into Facebook, so that strong DevOps culture was already there to some extent. Of course, like engineers from other fine companies as well. But they built a large, like a rich suite of internal observability tools. You know, we had ODS, which was their metric system, Scribe, which was their log aggregation system, and Scuba, which is an event system. And these systems have since gone out and gone into the market and become very successful methods of observability in general. Now, why do I bother with all this stuff? Like, I'm guessing that 90%, 95% of you are not Google, you're not Facebook, you're not that kind of giant company, you might not be Netflix or Uber or whatever it is. And so not everything that Google and Facebook does is something that you should do, right? It's not necessary, and it's not even applicable to companies at different scales. So that's just something to keep in mind. You don't have to just blindly ape them. But as our systems get more complicated, we should come to the recognition that these companies have built and operated extremely sophisticated and complicated systems for decades now. And they have experienced the pain of running and debugging these systems, keeping them up and keeping them running with very, very high uptimes. And when incidents do happen, how do you quickly remediate them? And that experience, it manifests as certain organizational practices and cultural ethos that you learn when you're in those companies of how do you build a system, what do you do when you build out a new feature, right? So it's a good idea to learn from these practices when they are applicable. And that's the reason why I bring all this stuff up. So with that cold open, I'm going to, what are we going to cover in the rest of this talk is what observability is, what's my point of view on observability and how it matters to you and your team and your organization. And when you're trying to adopt this observability in your team, what's the mindset and the tools and instrumentation that you might need, and how do you use that data that you're going to generate from all these observability practices. Okay. Now, why observability matters? So DevOps is an interesting thing where you kind of wear two hats at the same time. You're a developer and you're an operator of that system. And I don't think people fully appreciate the tension between these two roles. So as a developer, your job is to make changes to the system, right? You're building new features, you're doing bug fixes, you're improving the performance of this. Your job is to make changes to the system, not to sit back and just look at it. But as an operator, change is the enemy of stability, right? If you think about it, there are COBOL systems that run very happily on mainframes that are decades old. And they will continue to run for a long period of time as long as the hardware keeps going. It's because they've effectively hermetically sealed those systems and actively discourage any sort of change on that. Now, that is obviously anathema to the way that we do things. But making changes, of course, exposes the system to some kind of breakage, right? The environment is constantly changing. It can be your code that you're changing, even if you do not do a push, changes in configuration, changes in workload, libraries, and even if you do not do any of those things, Amazon can slide in a new kernel patch because of Spectre or Heartbleed or whatever you have and next day you wake up and all your systems are running 20% slower. And Amazon is like, thank you. So how do you operate in this world? Systems fail in innumerable, unpredictable, and exotic ways. If you have a chance, you can come in and meet with me afterwards in our booth. And I'll tell you the story of how my pride and joy, my analytics system that I built that has powered SignalFx, crashed and burned a few weeks ago because one of our teammates had Irish ancestors. So you cannot predict how systems are going to fail. And so failure is not an option, like it's inevitable. Your systems are going to fail in very interesting ways. Observability is what you need to help manage that breakage, what happens when things do go down. Okay. So now, one thing you might be thinking, and hopefully you're familiar with this, the difference between monitoring and observability is like, okay, I know when the system goes down because I have monitoring. What's the difference between monitoring and observability? Like, what is this creature called observability? And it's not really a difference in the tooling. Like monitoring and observability, you can effectively use essentially the same kinds of tools. You're answering two very different questions. When you're doing monitoring, you're asking the question, is it working? So you want to detect problems that might be affecting your customers. You might have black box type monitoring, or you might have white box testing, monitoring where you're actually looking into internal state. But it's fundamentally reactive in nature. Like if your system is working fine when you're doing monitoring, like you don't care. Like you don't have to go and look at it periodically. But observability is different. It's about what and how is your system doing what it's doing. So you want to improve your insight into complex systems. You want to observe what's happening inside and understand what the system is doing internally. You want to enhance your understanding of changes. When you make a change to the system, what is the difference in behavior? Visibility into internal state. And as a result, you have lots of interactions that are proactive to the system, where you go up to the system, even if your system is functioning perfectly normally, and ask questions from it and improve your understanding of what's happening there. And that is the difference between observability and monitoring. Okay? So let's talk about observability in your organization. So the first thing to kind of like wrap your head around is that observability is a methodology. It's a practice that needs to be exercised, right? It's a bunch of rituals and things like that you get into rather than just a bunch of tools. So people focus on, oh, observability, are you doing metrics? Are you doing tracing? Are you doing logging? And then they kind of like rub your hands off and they walk away. But it's not. It goes way beyond that. It's about how you approach that problem, what you do with that, and how do you make sure that you're getting the right data and then using that data effectively. Second, observability is not a Boolean state. It's not like that you have observability or you don't have it. I'm guessing that all of you, at some level, do have observability into your systems, right? I can't imagine that there's a company now that doesn't do at least some basic observability over here. But it's something that you can always get better at. And the third thing is that observability is a team sport. Okay? By this I mean that if you have sort of an uneven adoption of observability in your company, then you're going to have gaps into what's actually happening when something is broken. So it's not like where you have a team or a Scrum team that's building stuff together and say, okay, I do observability and the rest of you don't. It doesn't work that way. Now, it works even better when it's an organization-wide thing. But it doesn't have to be at an organization-wide thing. You can still do observability at the granularity of your team. And the thing about observability is that it's very hard to decree observability from above, to have a VP say, okay, all of you have to make your systems observable. There's only one situation that I can think of when that's actually a doable thing, is when you had a massive outage. And it's really affected your reputation, and it has really affected your money in dollars. And then the VP can be like, okay, guys, this cannot be. You have a compelling event. You guys have to sit down in the next 2 sprints and like make all your systems observable. That's the only reason that I can think of where you can actually have a decree from above. Otherwise, it has to be an organic thing that starts from within, bottoms up. Okay, so let's talk about observability in your team. So you mentioned, so if you recall, I mentioned that agile infrastructure is such a nice, it's actually a very nice characterization of what the DevOps sort of mindset is. And I really like the concept of agile. Scrum is one methodology of agile over here. But you can't help but observe that observability and Scrum have many, many things in common. And so if you have a Scrum methodology in your team, it actually makes observability a lot easier to adopt. So for one thing, like Scrum-based development, observability is a team-sized activity. I mentioned this before. A team is the right-sized unit to exercise the practice. And this makes a special sense if you're doing DevOps, as we'll see here. It's the whole team that's sort of involved in it. Like when you're doing Scrum, you can't say that, okay, I'm going to do, I'm going to groom my backlogs and I'm going to do task estimation, but nobody else is involved in it. Like that's not how Scrum works, right? And that's also not how observability should work. It requires the whole team to participate. Like Scrum, from the outside, it looks like it adds process and overhead. But the cost that you pay for those extra rituals and the extra artifacts that you do that's not a tax, it's an investment, right? It actually increases speed, efficiency, and confidence. And for those of you who do Scrum, you know what I'm talking about. And observability is very much that same way, where it looks like, now I need to add instrumentation to my code, I need to add charts, I need to add data. Why should I do all this extra work? I could rather just spend that time writing code. Like, that's sort of the wrong way of looking at things. And the Scrum Alliance says that here are the sort of like the 5 principal values of Scrum: focus, openness, respect, courage, and commitment. I would add here responsibility when we talk about observability. And let me tell you why. So your code modification can cause an outage 2 months from now because one of your teammates might have Irish ancestors. You don't know why this thing is going to break, how it's going to break. Systems break in all sorts of creative ways. You might not be the person who gets paged. If you are doing a DevOps practice, as a team, you have probably some sort of on-call rotation, and the person who gets paged is going to be one of your team members. You might not even remember this piece of code that you wrote. Put yourself in the shoes of that teammate who gets paged at 3 o'clock in the morning. They are not a domain expert in your system. What context do they need to understand what the heck is happening here? How do I fix this? Where is this broken? So observability is required to develop and deploy software responsibly. I would say it's irresponsible to write software and put it out there and not give your teammates the opportunity or the ability to figure out what the heck your software is doing. Now, I'm not saying that you have to go and instrument every single line of code. We'll get into that a little bit better. But here the issue is that breakages cost money, stress, and aggravation, right? And ultimately, we are responsible for the code that we write and we deploy. Any change you make is a risk to the system. Now, how do we deal with risk? So one can just shrug it and say, okay, there are certain risks, but there are actually frameworks to deal with risk. And there's this concept called ROAM. I don't know if you're familiar with it, but it's supremely useful to try and just think about risks. So when you have a risk, you can do 4 things with it, right? You can say, I'm going to resolve this risk. I do something so I make sure that does not happen. So your service can get slammed and DDoSed by some other client. It's possible. That's a risk. Well, you can add a rate limiter and resolve that risk so you don't get DDoSed. Okay? That's just resolving the risk right out. Owned is sort of an intermediate state. It's basically just like we haven't figured out yet what to do with this risk. I'm going to give it to somebody. I'm going to attach a name to it so that it doesn't fall between the cracks. But ultimately, it has to go in through one of those other 3 buckets. The third way of handling a risk is to accept that risk, which is to say, okay, you know what? A meteor might fall down on California and wipe it off the earth. That could happen. I'm willing to accept that risk. It might happen. Obviously, it doesn't have to be as dramatic as that. There are some business-related stuff, like how expensive is it to do DR for this particular system? How expensive is it to go from 4 nines to 5 nines? And you say, okay, it's not worth it, so I'm going to accept. And finally, the thing is mitigate, which is you do something so that you can reduce the impact of something going wrong, right? And having this framework and thinking about risks in this way is supremely useful. So if you think about your system breaking, now you cannot always resolve that risk if you don't know the way in which these systems are going to break. And like I said, they can break in very creative ways. You cannot just accept that risk because it's an outage. It's going to cost you money. And you can't just leave it down. You can't just say, okay, I'm going to accept that my system is going to be down. So the best you can do then is to mitigate it, which is to give yourself the tools to be able to manage those downtimes and to be able to quickly recover from it. So ensure respect and empathy for your fellow on-callers. When you push code there, give them the tools to be able to handle breakages in your system, right? So it's too dangerous to go alone. Take this. So give them observability. Give them the ability to understand what your code is doing. So let's talk about developing with an observability mindset. So the first one is don't launch to a Boolean. It's not just that the system has been launched and I'm done. When you're building a feature, you're trying to fix or improve something, and you should be measuring what it is that you're trying to improve. And when possible, and this should ideally be always, you should actually deploy that measurement before you start working on your feature. There's no way you're going to know whether you've improved it or you fixed it otherwise, right? So this is something that you can do when you create an epic, for example, if you're doing your Scrum type thing and you have a bunch of tasks to address this particular problem. One of those early tasks that you get out in an earlier sprint is to say, okay, first I'm going to measure what's happening right now. And then after you do your push, you can evaluate and see, well, how did I make things better? Did I make things worse? Did it not really move the needle? Second, as a team, consider what's your definition of done. So this is one of those things where you say you create these norms and these inter-team agreements of what does it mean for me to say that my feature is done, right? The code is written, that's a low bar. The code is documented, better. Code is tested, even better. But include, is the code instrumented, right? Have I created charts and detectors and alerts and all that stuff for it? Have I updated the runbooks for it? And don't close the epic till you've finished all this stuff. Like I said, your teammates will thank you for it. And so you put your shoes into what kind of information would you need if somebody else wrote some feature and pushed it out and you're the one who got paged. Well, just turn those tables around. And so if you're, for example, doing code reviews and you're looking at code, it's like, that's great, this looks pretty good. Why don't you add this instrumentation so that we can figure out if something breaks here, we would know what the issue is. So what should you instrument? So there are different mechanisms for getting information from systems. There are traces, metrics, and logs. You can do observability with any of them, okay? Don't get hung up on this, but I will give you sort of my point of view a little bit on when each of these form factors are appropriate. They are largely complementary. Traces give you information that the others two don't, and vice versa. And you can make do with any one of them. They are not mutually exclusive. They have different capabilities, levels of complexity, and use cases. I would say in terms of complexity, traces are probably the most complex, but they're also the most useful. You have to probably do a little bit of extra instrumentation for you to propagate context from one request to another request, especially if you're passing context across thread pools and things like that, asynchronous operations. But in return, you get a lot of sort of rich observability into what your system is doing. Logs are at the other end of the spectrum. It's really easy starting from your hi mom, I'm here, sort of like print message, all the way up to more complicated stuff. Logs are the easiest to do, and metrics are somewhere in between. But if you're just getting started, like I said, like don't sweat it. Like you don't have to like, oh my God, like which one should I do? Anything is better than nothing. It's good to get started. But that being said, it's better to consolidate in one form factor than spread yourself really thin across three of them. It's one thing when you saturate one, you have to have really good rich observability here, but I'm missing this sort of transaction-oriented flow. So then you say, okay, now I'm going to add traces. But if you're getting started out, don't say I'm going to do this with logs, that with traces. It's because these systems are like sometimes they are not very easy to correlate what's happening across the three of them. And that's the reason why I gave that recommendation. So if you're able to choose, pick tracing. It's a bit more work, but it's the most sort of insightful of the three. So KPIs and SLXs, I think I'd put this up here because there is a little confusion of what's the difference between a KPI and an SLI. So it's worth mentioning here. It's also the thing that you should monitor on rather than internal state of the system. We'll talk about that a little bit better. So a KPI is a key performance indicator, right? It conveys health, status, performance, usage, things like that. And the difference between a KPI and an SLI is that KPI is really tied to system implementation. It tells you what, so for example, if you have a service that's like, sending back widgets that have been stored in your system, when a request comes in, you might have to look at a database, retrieve that widget, assemble it, and send it out. So your database query latency, for example, is going to be a KPI. It's really going to affect how well your system is behaving. In contrast, a service level indicator is something that the user cares about. They don't care about databases. They care about how quickly you can return widgets to them, right? So it's a measurement of your users' expectations, and it might be synthesized from several different signals, but that's not the important part. The important part is to really capture user expectations of how your service is behaving. If you, for example, now say, okay, this thing is too slow, I'm going to front my database with a cache, and you install a cache. Now for you, the cache hit ratio would become a KPI. But for the user, their users' expectations have not changed. They are still getting widgets back from you. You're still looking at only the latency of serving out widgets. Does that make sense? Awesome. So an SLO is nothing but an SLI with some sort of thresholds and bounds that tell you what is an acceptable level of service and what's sort of not acceptable. And finally, there are SLAs. People tend to use SLA more than SLI and SLO, but actually SLAs are not our problem. SLAs are actually like legal stuff. It's about what happens if you break your SLO. It's an agreement that you have oftentimes with some sort of external customer. How much money do you get back and that kind of stuff. It's lawyer stuff, which I'm guessing like 99.9+% of us are not. So don't worry about SLAs. Think about SLOs and SLIs. Now here's another sort of like a pragmatic distinction between KPIs and SLIs and SLOs. Almost any engineer you talk to will be able to tell you what the KPIs of their system are, but very few of them have given any thought into what the SLIs and the SLOs are. So if you're getting started on observability, for example, it's a great team discussion to say, what should our SLIs and SLOs be? And that can be your sort of first observability challenge, to instrument that, expose that, monitor it for a while, make sure that it makes sense, and then you can actually start putting alerts on it and publicize that, okay, these are actually my service level metrics. All right? Cool. So let me talk about those three form factors. We have traces. And the way you should really think about traces is that they give you transaction-oriented observability. They tell you how requests flow through your system. So they capture, flow through various kinds of components and subsystems. And associated with traces are a whole sort of topology of spans. Each span has a bunch of metadata. It can capture context about the request that's coming in. It can capture various kinds of metadata about parameters that particular operation requires. It can really help you quickly localize a problem. If you see some request is taking too long, you can quickly find out, okay, what's the span? Okay, this is the span which is actually taking too long. And so you can really quickly localize and find out where the issue is. And you might be familiar with the concept of red metrics. And red metrics are basically requests, errors, and durations. These things are just obviously fall out from the tracing methodology. These are metrics that you can generate from traces. You can easily monitor them. For example, the durations, you can easily put on an SLI on them and then put an SLO, layer out an SLO on top of it. But like I said, it requires a little bit of extra work. Oftentimes, you need to add custom instrumentation code to propagate context across threads and things like that. But the result is, of course, probably one of the most useful ways of looking at your system. The second one is metrics. And the way you should think about metrics is that it gives you work and resource-oriented observability, right? Now, metrics are very compact. They are precise. They are ubiquitous. If you're running various kinds of systems in your environment, starting from Elasticsearch and Redis and Zookeeper and all that kind of stuff, you already have ways of getting metrics from those systems. So it's very quick and easy to get started on the metrics standpoint. And it's, of course, naturally amenable to visualization and analytics. All the other stuff, if you actually want to do things like anomaly detection, you have to convert them into metrics before you actually do anything interesting with them. And therefore, metrics actually lay at the bedrock of observability. So there are two ways of looking at metrics. One is work metrics, throughput, the number of widgets, the number of hamburgers. Like you can count those, and those are interesting and useful. You're basically measuring the work that your system is doing. And the other one is to think of resources. And resources, the methodology is like you have red metrics for traces, you have use metrics for when you're doing metric-related monitoring. And here you're measuring utilization, saturation, and errors. And the resources might be, it might be disk, it might be network, and it could be hardware resources. And here's where people frequently overlook, they can be software resources. Right? So if a span is running through your service and something really slows down, it could be a software resource that's actually getting saturated. This might be a cache, it might be a queue, it could be a thread pool that's filling up. So it really behooves you then to get resource metrics on software resources as well. And I'm not saying go and instrument every single array that you initialize, right? But if you're doing a microservice, it's hopefully doing something that's somewhat limited, and they might be conceptually a standard workflow where you get a request, you look it up in a cache. If it's not in the cache, you put it into a queue, you take it out of the queue, you look it up into the database, and then you serve it out, something like that, right? So then you want to say, okay, what's my cache hit ratio? How long are things staying in the queue? What's my thread pool looking like? And basically, that gives you enough insight to say, okay, the problem is not in the cache, it's getting stuck in the queue, right? That's useful. And finally, logs, which are event-oriented observability. Everyone's most famous thing, like I said, starting from your hello world printfs. So anything from script standard out are logs. And the sort of the complexity and the structure that you can put in with logs is a continuous spectrum. You can start with just blind text all the way up to very, very structured JSON documents. It's very flexible, but unless you really impose structure, there is very uneven in terms of signal to noise ratio. There can be a lot of crap in logs, and you'll have to go through gigabytes of it to find actually the thing that you're interested in observing, which can really like reduce the utility of the system. So the more structure you impose is better. It's very common to include timestamps, log levels, thread names, classes. Your standard loggers will do this already for you. And then you can take the next step forward in like, okay, I'm actually going to report the database query time and some information from user context, so on and so forth. And of course, you can extract metrics from this for visualization and show it in charts. So we have all these ways of like getting observability information now from our systems. How do we actually observe these observables? So even moderate levels of instrumentation can yield a lot of data, and it's easy to get disoriented in that data and not know how to consume it appropriately. And here by consume, I mean like to be able to visualize it, to be able to do alerting, any kind of automation you want to drive off of it. So how do you really think about consuming all this information? Because if you just put everything into like this giant dashboard that has like 50 charts in it, that's not going to help your grumpy 3 a.m. version of you. You really want to figure out how much context to provide and when. So in terms of monitoring, in terms of doing the alerting part, my friend and colleague, Corey Watson, who used to run observability at Twitter and Stripe, has come up with this thing called the case methodology, which is a nice way of thinking about monitoring. And here the idea is that when you fire off an alert, you want the alert to have a lot of context in it, right? Help the responder understand what's the scope of the problem, which system is it understanding, which system is it impacting, how big is the problem. So like as much information as you can give them at the time that the alert fires off, the better that they'll be able to respond to that alert. So you want it to be extremely heavy on context. Second is you want it to be actionable, right? If you send off an alert saying that CPU is high, so what? So what, right? Maybe it's high because people are doing lots of requests, and maybe that's good. So if your SLIs and your SLOs are not being affected, like who cares? So alert on the symptoms that are user visible rather than internal state in your system, right? Now there is one sort of like proviso to this. Sometimes internal state in the system are leading indicators of problems. Like for example, you're running out of disk. Right? Once your disk runs out of space, your system is going to crash. Then it's a good idea to have an alert on that. But other than that, like think really long and hard is like, can somebody do something about it? Because if your disk is filling up, then somebody can go and delete old files, for example. There's actually an action to do about it. So really think about whether your alerts are actionable, and if they are not, they should not. They should not be alerts. The other one is to be symptom-based, like I mentioned. Like really, is it affecting user experience, or is it something that your system will be able to recover by itself? And finally, evaluation, which is a way to just go back and reevaluate your alerts, make sure that they are still making sense. I re-implemented that part of the system, and now that these alerts and these charts don't make any sense. You want to make sure that you have this sort of a curation approach, so you go back and clean this content periodically. And in terms of observability, you have all this information. What's the best way to absorb this information? And here I would say that our VP of engineering and I are both aviation geeks. We love airplanes, and we do a lot of reading about it, and we get a lot of inspiration from airplanes and avionics on how to, we really think of like operating these complicated systems as you're flying an airplane. Like you have a flight deck, you have instruments, you have key performance indicators of what your airplane is doing, and you have a bunch of other state that's internal to the airplane, which you might need when you're debugging something in an in-flight emergency, but you don't need it to fly the airplane, so to speak, right? So that's the cockpit of an A320. In the center console between the two pilots lies a system called ECAM, Electronic Centralized Aircraft Monitoring. And basically what it is it's the aircraft tells the pilot what's the current system status. If there are any anomalies, they immediately show up on ECAM. You can click in and go into any particular subsystem, whether it's like fuel systems, electrical, hydraulics, and you can go and see like the status of individual systems, but ECAM at one flash will tell you what's happening in the airplane, right? So we've sort of like gone into this pretty heavily at SignalFx. This is our ECAM dashboard. This is our top level SLIs, SLOs, and KPIs. So these, what it's illustrating here are SLIs and KPIs, but embedded in them are actually SLOs. If there are any SLOs that are being breached, those numbers would be in red. And the idea behind this dashboard is that if there is an incident in our site, anyone from the CEO downwards, right down to the on-call engineer, can look at this dashboard and at a glance know what the issue is. And then we have detailed per service drill downs, right? So you can actually click through, look at the context for an individual service and go through like individual metrics on how that particular service is doing. Up there, we have like links to runbooks and links to various kinds of information that helps users understand and consume this information. So now you have this superpower of actually being able to consume your observability data. What are you going to do with it? So one is like you build a mental model of your system, right? Traces give a very useful information of system interactions. Use your dashboards to build up a model of how your system is working. So become familiar with your dashboards. What do these things usually look like in steady state when you're doing deploys? Do they have any daily, weekly, seasonal patterns? Are you aware of these even? So having them in dashboards and that you can easily get to is super useful in terms of consuming this information. Flagging bad deploys by looking at KPIs and SLIs. And then once you do your CI/CD, I like to think of it as another CI, which is your continuous improvement. I find this opportunity for improvement because, for example, the server is taking too long to start up, like, okay, maybe the cache is taking too long to warm up. What changes can you make to improve the system on an ongoing basis? And then to encourage curiosity and data exploration, right? So you have these dashboards. Sometimes you have them up there and you say, what's that? Like there's like a weird curve in there, and you can drill down and see what is the system doing, and it really helps you understand how your system behaves under varying circumstances. In terms of using these metrics, there's, think about it in your Scrum team and group meetings. You can do a general like system review, look at capacity reviews. How are we doing on capacity? Do we need to spin up more or less? And you can celebrate growth milestones. You launch this metric, and this metric shows that you've improved something a lot, and go order yourself a pizza. That's great. Sprint and launch retrospectives. This is, again, when you launch to not a Boolean, but to launch a metric, you should review that metric periodically, make sure that things are going as you expected. And then incident reviews are another excellent example and excellent opportunity for you to use this data. You can embed charts in incident reviews. When something goes wrong, you can actually embed the snapshot of the charts. Like, this illustrates exactly what happened, and this is what we did, and here's how it recovered. And to have those charts and dashboards around constantly is a great way. So that's kind of like how you use it in the context of your group. Now what happens, how do you get it outside your group? And here's this great word called stigmergy, thanks to Corey Watson again. And it's basically, how do uncoordinated systems actually go towards a common goal? Like how do ants, for example, coordinate and find that one bit of cookie that was left out there, and they all seem to find their way there. And stigmergy is sort of like the chemical and like distributed mechanism through which that works. But the issue here is that like good observability practices can really spread virally. Once you have these dashboards, open them up to your group, open them out to your company, show them in group meetings and team meetings, organization meetings, and show everybody what good looks like. Like once you have these great dashboards, there will be other groups that say, that's cool, I want to learn how to do that. So help these adjacent groups get started. And it benefits you because if you are using a system downstream of you, if that system is observable, it helps you. Because it might be that your system is working fine, but it indicates a problem because your downstream system is actually an issue. To recruit influencers, there are people in organizations who are exceptionally personable, very influential in organizations, and to get them, they can really help spread the word and get it going. And finally, when there's enough critical mass, observability will be empowered by the organization. So once you have some fraction of groups that are doing observability, there will be a consolidation phase where the organization will say, okay, we're going to decide on a tool, we're going to stand up an observability team who's going to empower everybody to get observability going, coming up with standard practices, standard sort of forms, formats for dashboards, things like that. But getting to that level of scale is a different problem. It's not a kickstarting problem. There's probably a whole nother talk on how you enable it in organizations. So in summary, I would say observability is a critical capability in an uncertain world. You need it to deploy changes responsibly. Observability is practice. It's not just a tool. So know how to use it in your development practices. Put yourself in the shoes of the people who have to carry pagers and respond to breakages in your code. Observability is a team sport. You really have to play together rather than just one person saying, I'm going to instrument my code, but everybody else is like, I'm not interested. And when there's critical mass, magic will happen in your organization. We've seen it time and again. So I'll stop there. I'm happy to take questions. I don't know how much time we have left, but. Not much, apparently. Thank you.